Hello everyone, I am Rahul Kumar and this is my team Dinesh and Adarsh. We built a machine learning model to predict Parkinson's disease using machine learning techniques under the guidance of our professor P. Gopalakrishna sir. Abstract. So what is Parkinson's disease? Parkinson's disease is a neurodegenerative disorder that primarily focuses on motor symptoms such as tremors, bradykinesia, rigidity, and postural instabilities. There are also other types of symptoms like non-motor symptoms. These are basically psychological, such as depression, stress, sleep disturbance, and anxiety. These psychological factors can affect the patient very much. So, early detection of Parkinson's disease is very crucial for timely intervention and management to improve the patient's quality of life. So, in our model, we used random forest algorithm integrated with grid search optimization and hyperparameter tuning. This hyperparameter tuning will give us better parameters that will help us to improve the accuracy of our model. This abstract outlines predicting model approach aimed at accurately predicting Parkinson's disease before onset of noticeable symptoms. Moving on to existing systems. Most of the existing systems out there implement various machine learning models such as SVM, support vector machine, random forest, logistic regression, biometric sensors, and clinical decision support systems such as image processing and etc. These existing systems have limited accuracy, so we cannot precisely say if a person has the disease or not. The proposed system uses random forest algorithm integrated with grid search optimization. By finding optimal parameters, we can efficiently detect the presence of Parkinson's disease. In proposed framework, machine learning algorithm uses hyperparameter tuning to find hyperparameters. These hyperparameters can improve the accuracy of our model. The proposed framework enables the model to accurately predict the results. Coming to dataset, we took our dataset from Kaggle. This dataset is composed of wide range of biomedical voice measurements of 31 people. Out of these 31 people, 23 people are affected with Parkinson's disease. Each column in this table is a particularly voice measure, and each row corresponds to one of the 195 voice recordings of these individuals. The main aim of the data is to identify the healthy people from the affected people. According to the status, we can identify these affected people. We given a binary output like 0 and 1. 0 is for healthy people and 1 for affected people.
Survey. One of the existing model which is proposed by Kamal Narayan Reddy and Venkata Shashank, entitled as Improved Approach for Prediction of Parkinson's Disease Using Machine Learning Techniques. In this model, it efficiently focuses on non-motor symptoms such as rapid eye movement, sleep behavior disorder, and olfactory loss, which precedes the motor symptoms. They used various ML techniques such as multilayer perceptron, Bayesian network, random forest, and boosted logistic regression, and they found that boosted logistic regression performed the best among the all above mentioned. And over the years, there are various algorithms which has been used for ML models for prediction of Parkinson's disease, such as support vector machines, random forest, neural networks, k-nearest neighbors, statistical methods, and hybrid approaches. The selection of the algorithms for the ML models depends upon the type of data set we are using to predict the presence of Parkinson's disease. Coming to the design part, we used various UML diagrams to represent the working of our model to predict the Parkinson's disease, and this is our architecture diagram which represents the flow of our working of our model. Basically, we import the data from the data set, then we perform data pre-processing, and for training the model we use random forest algorithm integrated with grid search and k-fold cross validation. We perform grid search on the certain parameters of the random forest to find the best set of hyperparameters that is best suitable for training the model, which aims to improve the efficiency and performance of the model. By using the k-fold cross validation, the performance of the each model by using certain set of hyperparameters which are predefined in the parameter grid are evaluated, and it is done for k number of times, where k is the number of folds we use for k-fold cross validation. Then the parameters which perform better and gives the better results is used for final training of the model. Then the results is based on the final training which is being trained by the model. Implementation. This is the code that we used in our model. As you can see, this is the interface that we built using a Streamlit interface, and we have to enter the values in the input fields as specified in the interface. Then it will predict whether the person with the given parameter values is affected with Parkinson's disease or not. Let's enter some values. As we can see that it is showing the result as 1. So we can say that the person with these parameter values is affected from Parkinson's disease. Results, as we can see that the accuracy of a model is 94.8%. So by this we can say that our model is efficient in predicting the presence of Parkinson's disease. It performs better than most of the other models. Coming to a conclusion, even though our model got the accuracy of 94.8%, there is a scope for improvement of accuracy and performance of the model, right from the size of the dataset to the categorization while training, and by using various hyperparameter tuning techniques other than which are used in our model.